so we're moving into early members of the genus Homo. So if you were following along with the readings and the slides for the Australopith section, chapter 10 in your book, uh, there were some possibilities for the ancestor to genus Homo that were in the last slide set in 10b. Some of the uh, good options for being direct ancestor to the genus Homo include, I think probably the best option is Australopithecus gari. So you can go back and look at Australopithecus gari. So we're moving into genus Homo, and one thing I wanted to talk about a little bit before we get into any members of the genus, any species within the genus, is how we recognize members of the genus Homo. So if we look in the fossil record, if we find a fossil that dates to 2 million years ago, how do we know what it is? How do we know whether it is a member of the genus Homo or if it's a member of the genus Australopithecus? So there is overlap between the two genera. So there's a period between about 1.5 million years ago and about 3 million years ago where we have a lot of complexity to the fossil record. So we have lots of different species and members of two different genera that are sharing the landscape in Africa, both in East Africa and in South Africa, and it's kind of an ongoing question within the field as to how these species relate to each other, who is directly related to who is ancestral to whom, all of that kind of stuff. It's an open question, and it's the subject of a lot of debate in the field. So we have so much fossil material from this time period, and we aren't really completely sure what to do with it, like how to interpret these evolutionary relationships between all of these different species. So back to the question I asked a minute ago, if we find a skull that dates to 2 million years ago, how do we decide whether it's a member of the genus Homo or a member of the genus Australopithecus? Okay, so what characterizes the genus Homo? Listed on this slide is what I have described here as the traditional definition of the genus. So this is a definition of the genus that was written back in the 1970s by a paleoanthropologist named Louis Leakey. He had found the first Homo habilis specimen, which is a species we'll get to in just a minute, and he wanted to come up with some kind of way of establishing a dividing line between Australopithecus and genus Homo. So what characteristics have to be present in order for us to name a member of the genus Homo? So he included in his definition having an absolute brain size of 600 cc's or more. So 600 cc's, of course, means 600 cubic centimeters. So having a brain size of at least 600 cc's is what Leakey thought was a good threshold, a good cutoff point, establishing, differences between genus Australopithecus and genus Homo. So I do want to say that this using 600 cc's as a cutoff is more or less arbitrary. If we look back at Leakey's original definition, basically he wasn't completely unbiased in choosing 600 cc's. So he had just found a new species, a new specimen that had a brain size of about 630, somewhere around there, and he believed that the specimen that he had discovered was in fact a member of the genus Homo. So when he wrote this definition, he was kind of keeping in mind that he considered his new discovery to be a member of the genus Homo. So this absolute brain size cutoff is a little bit arbitrary, but it's one that that is still, I don't know, kind of more or less used within this definition of the genus Homo. The other items in this definition are a little bit more tricky. So possession of language is not something that you can tell, not really something that you can identify from the fossil record with any kind of ease. So he included possession of language in his definition because he believed that once we see a certain threshold of brain size in hominin evolution. The complexity and size of that brain would indicate an ability for human-like language. So he included possession of language in his definition of the genus Homo, but I think that is a problematic part of the definition. So if I was writing one myself, I would probably take that out, just because there's no way of firmly establishing when exactly human-like language appeared within hominin evolution. The third item, the ability to manufacture stone tools. At the time, back in the 1970s, when the Leakeys found their earliest specimens of Homo habilis, Homo habilis was the earliest species known to have used stone tools. So this ability to manufacture stone tools, part of the definition, is again related to the material that they had just found at the time. So a lot of new discoveries have come about since the 1970s, obviously, and we now know that the earliest stone tools have been dated to around 3.3 million years ago, which is much older than anything that was previously known to have existed. So prior to this discovery, this site that dates to 3.3 million years was just discovered a few years ago. Prior to that, the oldest stone tools were 2.6 million. So a lot of time depth has been added just over the last couple of years. So this is probably also not a great thing to use in your definition, the ability to manufacture stone tools, because we now know that hominins were making stone tools as early as 3.3 million years ago, which would mean that probably Lucy's species was capable of making stone tools, at least some form of rudimentary stone tools. The last item here, a modern human-like precision grip. This actually kind of ties back in with the ability to manufacture stone tools. We talked a little bit about the precision grip earlier in the semester. Humans, all primates have some form of a precision grip. Basically, we have the ability to we have an opposable thumb, which gives a lot of flexibility and potential for a good grip to our hands. Humans have an exaggerated version of this. So we have a highly mobile joint at the base of our thumb, and it allows for a lot of flexibility in that grip and a highly precise grip. So we're capable of picking up small objects, manipulating small objects. This ties back in with the last item, the stone tool item, because we have to have a degree of precision to our grip to be able to make and use stone tools effectively. So we're better able to manipulate those objects to both make and use stone tools once we have this precision grip appear in the in human evolution. Okay, so Homo habilis is the species that Lewis and Mary Leakey found in the 1960s. This was the justification that they used for writing that definition of that traditional definition of the genus Homo in the 1960s that we just talked about. It was basically describing this material. So the Leakeys found the first Homo habilis material in Olduvai Gorge, which is in East Africa. The material, we now have a ton of fossil material from this species from all over East Africa. It all dates between 1.5 and 2.4 million years ago. It looks a lot, it looks like genus Homo, but it also has a lot of primitive characteristics. So some people in the field describe Homo habilis as being kind of a transitional species. It's like bridging the gap between Australopiths and members of the genus Homo. Brain size is 630 cc's. Again, when Louis Leakey found the first Homo habilis specimen, he wrote the definition of the genus Homo based on this 630 cc brain size. Okay, another early species, Homo rudolfensis, found also in East Africa in the 1970s. The first member of this species was actually found by Lewis and Mary Leakey's son. The material dates to around 1.9 million years ago, so within the same time period as the Homo habilis material. Brain size is a little bit larger, 750 to 775 cubic centimeters. We see basically pretty similar characteristics to what we see with Homo habilis. Everything is just a little bit more exaggerated. So larger cheekbones, larger teeth. As it says here on the slide, basically everything is bigger than Homo habilis. So this slide is comparing the two. So this number here, KNMER 1470 and then KNMER 1813 are specimen numbers. So we're comparing two individual fossils here. The Homo rudolfensis fossil has a larger brain, so 775 cc's as opposed to 630. Brow ridge differences. Rudolfensis has no brow ridge. Homo habilis does have a brow ridge. You can see here comparing the two, this brow ridge is pretty prominent on the Homo habilis specimen and a little bit less prominent over here on the Rudolfensis specimen. We have a large face versus a small face and large back teeth versus small back teeth. So these species were around at the same time. They were both in East Africa. So one of the questions is which one of these species is directly ancestral to us? So if we had to guess, just looking at the breakdown of information that we have here on the slide, the larger brained individual is probably a better bet. One last thing that we'll talk about is the archaeology of early genus Homo. So the term Oldowan tool industry is one used to describe tools that look like this. So you can see these are pretty primitive looking tools. They don't look anything like a spear point or anything like that. It's much too early for those sophisticated types of tools. Up until a few years ago, these were the oldest known stone tools. So the earliest Oldowan tools dated to about 2.6 million. They were associated with Australopithecus gari, and of course members of early genus Homo as well, so Homo habilis and also Homo erectus. Up until a couple of years ago, they were the oldest known stone tools. There is that site I mentioned before that dates to 3.3. It's a site called Lomekwi. You can see this term here. That is the 3.3 million year stone tool site. So this is just a very, very brief introduction to early Homo. We will move on to Homo erectus at this point. Okay, so Homo erectus is the first hominin known to leave Africa. So the slide here, the picture on the slide that you're looking at here has a comparison of a Homo sapiens, so modern human specimen, a Homo erectus specimen, and then in the middle here, an Australopithecus specimen. So what this picture is demonstrating is that we see a big step forward in human evolution occur with Homo erectus. So we see a real transition from more primitive looking hominins to hominins that look a whole lot more modern in their anatomy. So we see a new kind of hominin. So the earliest East African specimens, it says here on the slide that they date to 1.8. That it has been true. I actually just saw an article the other day that a new, I think in South Africa, a new South African specimen has been discovered that dates to about 2 million. So that number, that 1.8 number, might be a little bit out of date as of 2 weeks ago. So somewhere between 1.8 and 2 million years is when these specimens first appear in the fossil record in Africa. As far as what they, the way that they lived, we know that the earliest specimens were using these Oldowan tools, so these very simple tools here that we see. Basically, these were created to have a sharp edge, so probably used to cut meat off of scavenged bones. So we have Oldowan tool users. They lived in a variety of different types of environments, lake shores, riversides, forests, and grasslands. We know that they were the earliest intensive meat eaters. So meat consumption was probably happening earlier in time, but we have a big emphasis, a growing emphasis on meat consumption with Homo erectus. So the earliest members of the species, earliest Homo erectus from around 1.8 to 2 million years, were probably scavenging. So they were probably like their earlier, Homo habilis ancestors, just cutting meat off of bones that had been killed by other animals. We almost immediately start to see a transition with Homo erectus into active hunting. So later periods, we see evidence of them being very skilled hunters and very reliant on meat products in their diet. Okay, so Homo erectus arises in Africa about 2 million years ago. He starts to leave around 1.8 million years. We see Homo erectus sites in Eastern Europe, in the country of Georgia, at a site called Dmanisi that dates to pretty close to 1.8. And then we have other material as far afield as Indonesia. So in Southeast Asia, we have material that dates to pretty close to 1.8, probably about 1.7. So by 1.6 million years ago, we have Homo erectus living in 3 distinct regions, in East Africa, probably in South Africa as well, in Eastern Europe, and in Southeast Asia as well. Okay, so what do these specimens look like? From a body size standpoint, we're starting to see full human-like body size. So these specimens average over 100 pounds for estimated body mass, average of 5 foot 6 inches in height, so well within the modern human range of height. They are highly sexually dimorphic, meaning the males and the females are of different sizes and robusticity. But across the board, all of these individuals, whether male or female, are more robust and more heavily built than modern human populations. So very muscular, heavy individuals. In terms of brain size and crania, we have a brain size range of 700 cc's all the way up to 1250 cc's. So 700 cc's is pretty small. It's kind of within the Homo habilis range. And then we have all the way up to 1250, which is just beginning to edge into the modern human range. So modern humans average somewhere around like 1350, 1400. So we have brain sizes that are kind of edging into modern human size range. So one thing to mention about this range of variation in brain size from 700 all the way up to 1250 is that Homo erectus is a really long-lived species. So they appear around 2 million years ago in Africa, and they don't go extinct until much later. So maybe 50,000 years ago, maybe as late as 50,000 years ago, there were pockets of Homo erectus living in kind of remote parts of the world. So what we see here is that brain size really corresponds with time. So the very earliest specimens tend to have smaller brains towards the 700 cc's side, and then the late surviving populations have brain sizes up around 1250. So a lot of range for brain size. We have pretty heavy skulls, thick cranial bone, big brow ridges, sloping foreheads. We have skulls that are a little bit different in shape than modern humans, so the overall aspect of the skull is shaped differently. And we have something called a sagittal keel as well. So we introduced the term sagittal when we were talking about robust. The sagittal crest in a robust serves as a muscle attachment point for chewing muscles. The sagittal keel is not the same thing. It is basically a thickening of bone. You can actually kind of see one here. It's a thickening of bone in the same location, and it does not serve as a muscle attachment point. Okay, so cranial anatomy is summarized here. Thick cranial bone. This term supraorbital torus just means big brow ridge. Occipital torus means that we have a lot of thickness and heaviness to the base of the skull here in the back. We have the sagittal keel, which I pointed out before, and we have an overall difference in shape of the skull, which is not really visible in either of these pictures. But we also have a sloping forehead. You'll note that this forehead slopes directly back. Instead of being vertical like a modern human skull, it kind of slopes straight back. In terms of postcranial anatomy, so postcranial again means everything below the skull. From the neck down. So we have a trend towards larger body size, longer legs. The femur is the thigh bone. So we're beginning to see the beginnings of modern human body plans. Okay, so there's a couple of things I'm going to skip over here. I do strongly recommend that you go through these slides and follow along in the book, but in the interest of keeping these recordings relatively short, I'm not going to cover everything in the voice recording. So I'm going to skip forward a little bit and talk a little bit about stone tool technology. So we introduced the Oldowan industry before. So the Oldowan was it's one of the oldest types of stone tools. You can see in the picture there. They're very primitive. Again, probably just being used to scrape meat off of bone. Very, very simple, kind of primitive tools. So the Oldowan tool industry was around from 2.6 to 1.4 million years. We know that Homo habilis and Homo erectus were definitely using the Oldowan type tools. Australopithecus gari might have been, they probably were. So we do have a transition after 1.4 to better forms of technology, more advanced forms of technology. So Homo erectus is associated with something called the Acheulean industry. The Acheulean industry appears in Africa at about 1.6 million years. And if you look here at the pictures on the slide, these tools are much more sophisticated than the Oldowan tools. So you can see they look a lot more recognizable as something made by hominins for specific purposes. So if we compare these pictures to the previous slide, there's a big jump in technology there between the Oldowan tools and the Acheulean tools. So we see these tools appear first in Africa, and then they're taken into parts of Eurasia. There is a lot of consistency across space and time for this tool type. So a lot of these tools look exactly like what you see in the picture here. The fact that they all look so standardized has implied to a lot of researchers that we have, quote, imposition of arbitrary forms on the environment. So basically what we have to have here in order to have such a degree of standardization is we have to have a purposeful intent. We have to have kind of a mental template that is in the head of the hominins that are making these tools, and we have to have kind of a purposeful execution, as opposed to something like this that doesn't require a lot of imagination or forethought. You have to know what you're doing in order to make something like an Acheulean hand axe, and that's what we're looking at here, pictures of Acheulean hand axes. Now, these were used specifically for active hunting. There is a site in Kenya called Olorogozile. This is what a reconstruction of the site looked like. It is a Homo erectus site dating between 600 and 900,000 years ago, and we have many, many hand axes that were found at this site. So if you look here at this reconstructed site, all of these what looks like rocks scattering on the ground, those are not just rocks, those are Acheulean hand axes. So many, many, many hand axes were found here. They were also found in conjunction with broken up and cut marked hippo bones. So these are some of the hippo bones pictured here. So a site like this shows us that by 900,000 years ago, Homo erectus were very accomplished hunters. So hunting hippos in modern times, like hunters that want to go to Africa and hunt hippos, even with automatic weapons, it's a very dangerous thing. It's a very difficult thing to do. So if you can imagine that these Homo erectus individuals must have been very skilled hunters to be able to kill game as large as hippopotamus with just these hand axes. The last thing we'll say about the Acheulean industry is that it only appears in certain parts of the Old World. So the areas that have the hatch marks on them on the map are areas where we find Acheulean tools. So all over Africa, in parts of Europe, and parts of Western Asia, Western and South Asia. To the east of this line, we don't have any Acheulean tools that have ever been found. So this line was first demarcated by an archaeologist named Movius, so it's named after him. So there's kind of a question of, why don't we see Acheulean tools to the east of this line? There could be any number of reasons. Maybe the technology just never traveled that far. It's also possible that individuals living in you know, to the east of this line were using some other type of tool technology. Maybe they had other raw materials that were available. It's been speculated maybe that they were making tools out of bamboo. Bamboo would be a really good thing to make hunting tools out of. And the idea is basically that that bamboo doesn't survive in the fossil record. So the Mobius line demarcates where we find Acheulean tools versus where we don't.